the main thing is to capture whatever I write on the board. So, like after I'm done filling up that board, I'll start filling up that board, at which point you want to pivot. Yeah?
I have a question about my lab. Or my math lab.
Question about my lab?
Yeah, there's like two different options.
Oh, okay, I got
So
it.
did you get like that? I didn't know if there was like, if you knew that.
There's
Okay,
two
so-
different options.
Yeah, when you go to, I didn't know if you knew if one like lasted longer than the other. One's like 18 weeks and then the others, it doesn't say how long it lasted, but I didn't know if you had information on how long that lasted for.
I don't know for sure like what all the different options mean. I mean, I gather 18 weeks means you get 18 weeks access. What the other one is, I'm not sure.
Okay.
I mean, the class is 15 weeks, so like if, suppose you take this course and everything goes well.
Right.
Yeah, you worked, right?
I have more math classes, so I was just didn't know it.
Well, so it's not guaranteed that the next math class will use Pearson. It may or may not. I mean, we do have some courses, like I know physics is largely in Cengage, which is WebAssign. Well, WebAssign is Cengage, I should say. But so it's hard to say right offhand, like what's the the best purchase choice. Like if you have a higher level math class with me, like Math 131 and above, if I teach it, I don't have electronic homework, period. I assign paper homework, you hand it in with paper, we have graders grade it. We just I don't think have enough graders to handle paper homework from 121 students. Like it's just too much for other department, yeah.
So the course ID to enroll in a course on Pearson, that's the one that we have to buy?
There is no course ID for Pearson. What you have to do is you have to go to Canvas and you go to My Labs and Mastering, you get in there, you agree for your firstborn to be named after Pearson. I mean, you go through this long list of legal mumbo jumbo, blah, 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 accept. Then that will take you to the login screen for most of you, like the login to Pearson screen, you log into that, and then it should say like, you can either pay for it with like a credit card, or you can use the course copy code, course access code. It's not a course ID, it's access code. That course access code you have to purchase either bundled with something in the textbook, either like the ebook bundled with it to the bookstore, or the loose leaf copy bundled with it to the bookstore. Or like I said, you could just pay for it with a credit card there. And even then, there's a couple options in terms of paying for it, because you could either buy the 18 weeks access, I think, for $75, or what were you just telling me the other option was? A year, like all Pearson all in.
Yeah, there's like two options, and one's like 18 weeks, and the other one just doesn't say how long it's for. So I just didn't know.
Yeah, unfortunately, I can no longer see that screen. Like after I log in once, it's gone for me. So I'm just going off memory. Okay, so let's get back into the math. If you have questions about like logging into homework and stuff, you should come talk to me in office hours or something. Unfortunately, I really can't take too many questions after class because I have a class after this. Again, we only have 15 minutes between class, and it takes me 5 minutes to set up the camera. Blah blah blah. Everybody get to sign the sheet. Yeah. I should mention. So there's that. So there's your top half. Let you guys do that.
Did you create a Pearson account for my one? Or not? Yeah.
All right. Well. I'm going with Teams today, but the thing is, my computer apparently has no microphone. That's interesting. That's going to make this exceedingly silly. All right. Okay, so any questions about the math here as I get started? Listen, I don't think it's an issue for your course, but for some of my college algebra courses, so the way I started this semester was I had somebody else's college algebra in Canvas, and then what I did was I deleted all of their stuff, right? And then I started afresh and built your course, right? So if I accidentally miss something in assignments, it might still be there. So if there's something that appears in your schedule which is not on my my course planner, it's probably not real. You should email me about it and say, hey, like, Dr. Cook, it says I have a quiz on Sunday. Is there really a quiz on Sunday? Because you didn't talk about that anytime else. It's just appearing in my Canvas to-do list. So like if that sort of thing happens ever, like just email me, please, because it just means I missed something in the Canvas setup. I'm going to comb through my courses and try to make sure I've deleted everything, but I know I missed something, and I think it was the earlier section. I don't think it affects you guys, but I'll find out for sure when I have a couple hours to sort through Canvas again. All right. So let us continue the factoring. Example 1. Let's look at 5x squared plus 14x plus 8. Let's see if we can factor this thing. All right. So what I'm going to do is I'm going to put 5 like that and x like this. And hopefully that will allow us to do it. Can you guys, any suggestions? I have an 8 here, right? Yep.
4 and 10.
A 4 and a 2?
10.
4 and 10. Oh, I want it. 14 is 4 plus 10. Is that what you're saying? So the question is, how can we get a 4 and a 10, right? We could get a 4. Oh. I guess if we put a 2 here, right? That would give me 10. And if I put a plus 4 here, that would give me 4. So I get 4x plus 10x gives me 14x. Very good suggestion, yeah. So there you have it. Factor. Any questions? Now, there is an even simpler kind of problem I've not covered with you guys yet. Let's get that out of the way here. What if we had something like 3x plus 7? Could you factor that? I mean, ordinarily I would just say it's already in simplest form, right? But if you did want to do something just for the sake of doing something, you could factor the 3 out, right? So 3x plus, how do you factor a 3 out of 7? Like this, right? That's 3 times 7 over 3. So if you use your imagination, there's a 3 and 7, just like that. And once I have a 3 here and here, I can pull it out. So I mentioned this because there's like a problem or two in your homework where they want you to factor a number out of the linear thing. Like, okay, problem or two like that. Now, I don't usually expect you to do that sort of thing on other problems. Let's see here. Example 3. Here we've got 12x cubed plus 10x squared minus 12x. All right. And the instructions for all of these is factor if possible. All right. Did you already move it? Oh, cool. So guys, can you tell me anything here? Like, what can we do? By the way, if you missed it, the beloved Top Hat code is sitting in the board. As a point of classroom organization, I try to put the Top Hat code somewhere in the corner like that. And eventually I will remember to mess with the power settings of my laptop so it doesn't turn itself off after 2 minutes of non-use. For moment, if you come in late and like my computer has turned itself off, just say, hey, your computer's went to sleep, I'd really like the top half, so please wake it back up. Yeah, okay, just communication is key. If you can't do something, let me know. Okay, so getting back to the math here, what should we do? Yeah,
Pull the greatest common factor.
Okay.
So like 2x.
I like that, 2x. Pull the greatest common factor out of 2x, and if I do that, that leaves me a 6x squared here, right? A, what, 5x? And a minus 6, yeah. Cool. Now, can we do more? I think we can do more, right? I think we can further break this one down. Let's say 3x, 2x, like that. And I'll fill in the rest of it, the different color here. What do you think? Well, we need a negative, right? So I'm thinking either 1 and 6 or 3 and 2. One of them's got to be plus, one of them's got to be minus, right? What do you think here? Let me just try one, right? Like minus 2 plus 3, did that work?
Plus 6 minus 1.
Well, first of all, let's see if this one worked, right? 2 times 2 is 4, right? 3 times 3 is 9. So I got 9 minus 4, which is 5. I think we got a winner. I think this is it, right? So, sorry, it's not the greatest for your learning. I accidentally guessed the right answer to start with. You know, let's try your 1 and 6, see what happens. Right?
That's the other one. No, plus 6 minus 1.
If I did that, plus 6 minus 1. I know this isn't going to work because mine worked, and it can only work one way. As I was saying, math is not postmodern. There's only one truth. It's not like you can have your truth and I can have my truth. Like the factorization of a polynomial is unique up to reordering. So, this is plus 12x and minus 3x, which gives us 9x. But as you can see, the middle term is 5, right? So, I mean, this is a potential way to factor it, but it's not how this one happens to turn out. And now I forgot what I had there before, so you have to remind me. Which one did I put, 3 or 2? I did a what? I did a what?
Minus 2 plus 3.
Minus 2 plus 3. Now, but I'm glad you said that because for one of these problems, there's different choices to try, and you try them, and if it works, and if it doesn't, you try another one, right? This is guess and check. And that's pretty much the fastest way to factor. There is another ironclad method for factoring any quadratic polynomial, which I'll share with you in a future class. So there is a way you can do it without guessing and checking, but it comes with a higher arithmetic burden, so I'll get to that later. We should always try to guess and check factor as a first line of defense, all right? So let's go on here. Next up, example 4. What if we're facing x to the 4th, all right, minus, I don't know, 64. Now this one, we haven't quite run up one like this yet, but I will tell you what I told my previous section, which is that in pretty much every college algebra first test I've ever given, I have this problem. Or something like it. This is like a standard problem I always put on my exam because it's just it's a medium problem. It's like, I can tell the difference between an A and a B student. Well, not an A and B, maybe a B and a C student here. So what you gotta do is you gotta look at it like this, right? X to the 4th is x squared squared, right? So we think about kind of a substitution here, really. Think about our difference of squares formula, right? This is like a squared minus b squared is what? A equals to x squared, b equals to 8, right? And remember what we learned last time, or remembered last time, is that a squared minus b squared is equal to what? A minus b, right? Times a plus b. And so with x, a equals to x squared, and with b equal to 8, what do we have? squared minus 8 and x squared plus 8. Right? Do you guys follow? Okay, so can we factor this further? I think we can. Now, one of these we can't. X squared plus 8, that's like it. Game over. This guy is prime. How can I know that that's prime? If you look at it, we have x squared plus 8. If you think about that as ax squared plus bx plus c, right? By the way, this big A and that big A, not the same, right? I'm using the letter big A in a logically different way at this point, so you know. So looking at the coefficients here, I've got A equals to 1, B equals to what, C equals to what? What's the coefficient of x in x squared plus 8? So I tend to graduate, yeah?
0.
Ah, very good, yes. I was going to tell you a story. So when I was in graduate school of physics, I had this great solid state professor, but I mean, this guy will probably at some point, it wouldn't be surprising to see him win like the Nobel Prize in physics. He's just brilliant. But he had a very strong stutter, like that, you know? And so once he's like, he told us that every elephant has wings. And he didn't just say every elephant had wings. He said every elephant had wings, but it was like buried behind like a half a minute worth of stuttering. It was like, what's he saying? You know, that kind of thing. Anyway, so we're like, what? He's like, yes, they're just set to 0. So that's kind of like this. The x term is set to 0. But anyway, it's funny to me that happened. Let's see here. So that's one of the joys of having 4 sections of college algebra. I'll be doing experiments this semester. I'm going to find a joke, I'm going to tell in each section, and then like compare and contrast how the different sections react. Unfortunately, I missed my chance. I did not tell the elephant with wings story in the earlier section today, so that's off the table. I know it bombed in here, but I can't speak for the other sections. So A equals 1, B equals 0, C equals 8, right? And remember, we looked at the discriminant, b squared minus 4ac. In this case, that's 0 squared minus 4 times 1 times 8, which is minus 32, which is less than 0. And the theorem I told you guys last class is that shows us that that is prime, right? We cannot factor x squared plus 8. It's a prime polynomial, that's it, end of story. Okay? On the other hand, what about x squared minus 8? Very different, right? So what we have here is x squared minus the square root of 8 squared, right? So then we can factor that. That's x minus the square root of 8, x plus the square root of 8, times x squared plus 8. There you go, that's as far as we can go. It's factored completely. I don't think there's one like this in your homework. Your homework's actually friendlier. Your homework chooses numbers to put here that happen to be a whole number to a 4th power. It works out nicer when that happens. Yeah. Here, let me work a nicer one of these. Like, what if I had x to the 4th minus 16? How would that go? See, that's x squared squared minus 2 to the 4th. So, or I could write it this way, 4 squared, yeah. So we're looking at the difference of squares. So this is x squared minus 4 times x squared plus 4. I took the training wheels off this time, right? Like in the previous problem, I wrote down a equals x squared, b equals 8. So just to lock us into the difference of squares pattern and apply that, right? Do you have to write this down? Like, no. You know, if you understand the pattern here, you could go straight from here to here. That would be totally legit, right? Okay? And that's what I'm doing over here. took the training wheels off, I'm not writing down the A and the B explicitly, okay? And then what? Well, you know, anytime we have x squared plus a number, that is prime. Okay, like what we just worked out here, it's gonna happen again. Okay? So this one is prime, we can't factor that further. This one, on the other hand, we can factor, right? What's x squared minus 4, how's that factor? X plus 2, x minus 2. This is correct. Any questions? Let's look at a slightly weirder looking example. Example 6. We have a plus g quantity squared minus 64. We're supposed to factor this thing. Yeah. Okay. So you can over here. So what do you guys think? I think we should make a substitution again, right? Let's look at this as being a squared minus b squared, where a is equal to what? A plus g, little a plus g, right? And b is equal to 8. Right, that's the pattern. It's the difference of squares. And so, again, a minus b, a plus b. So that's little a plus g minus 8, little a plus g plus 8. And that's the end of the road right there. So let me do another one that's kind of like this, but a little bit different. So here we have 4 times n minus 4 squared plus 20 times n minus 4 plus 25. We're asked to factor this completely, right? So I think this kind of problem, it's really healthy to like make a substitution so you can see the pattern you're working with. So what I'm going to do is I'm going to let x equal what? What do you think I should let x equal? N minus 4? I think that's a good choice. So we'll let x equal to n minus 4. Now with that substitution, this just becomes what? 4x squared plus 20x plus 25. Can we factor that? Hopefully. It's not something I said. Let's see here. Let's see here. So I haven't said anything too politically incorrect today yet, have I? Not really. I have to be careful. Like, you know, it doesn't take much to get YouTube videos pulled down these days. So, like, you know, careful not to say the wrong thing. Our digital overlords may be watching. Let's see here. So how about 2x and 2x? I think that'll be nice. Because 4x squared you can get from 2x times 2x. Now, of course, you could also try x times 4x, but I think 2x and 2x works. Right? Well, let's find out. Guess and check, right? How do we get 25? 5 times 5 is one way. Does that work?
Yes.
So we get plus 5, plus 5. Now, FOIL it out, right? 5 times 2 is 10. 2 times 5 is 10, so we get 10x plus 10x, which is 20x, good. 5 times 5 is the 25, and of course the 2x times 2x is 4x squared, we're good.
But can you do it to 2x plus 5 squared and simpler?
Yeah, let's simplify this, that's a good idea. So that's another way to write that, which is good. And now, we're not done, right? If our question starts with the letter N as in nanu nanu, does anybody know what I'm talking about? No? Yeah. People barely knew what nanu nanu was in my generation, much less yours. That is reference to a forgotten TV show called Morgan Maine. Let's see here. So that's 2 times. So we would like our answer in terms of N rather than X, right? X was something we invented as a sort of middle step, just to make our work easier. Yeah?
So would you want us to distribute the 2 or just leave it as is?
Oh, yeah, we're not. Yeah, your book wants you to. And I guess, just good practice here. So that's 2n minus 8 plus 5, quantity squared, which of course, final answer, 2n minus 3 quantity squared. Now, I will say, if this was a test, right, and you left your answer as what I'm about to underline in red here, I would probably give you full credit. I might take off like a half a point or something. It really rests on the question of whether or not I put the word simplify your answers at the preamble of it, If you left your answer without N in it, then I'm more likely to take off something. But goodness gracious, if you took this and you got to that and you just forgot to switch back to N, I'm still going to give you probably at least 3/4 credit, because the lion's share of the effort here is, in the factoring, the undoing the substitution at the end. That's just, what's the word? Bookkeeping. All right, one more factoring example, then we'll be done. Factoring here. So here I have a plus 4 to the 3rd power plus, let's see here, 729. Now, so a lot of you don't have the number sense to go, 729 is log cubed, right? So if you don't have that number sense, but you do have a calculator, what you can do is say, look up your calculator, find the cube root function, right? Put 729 in it, and what do you get? 9. 729 is 9 cubed. See, so this is, let's say this is a cubed plus b cubed, where a equals to little a plus 4, and b is equal to 9. Now, if you can't find the cube root function on your calculator, you could also do to the 1/3 power. That's the same logically, right? The cube root is the 1/3 power. Need more help with that sort of thing on my office hours? I'll tell you. Okay, so remember we had a formula for this? What was it? Was it a plus b times a squared minus ab plus b squared? Was that it? You guys got that formula sheet, so you tell me. Do I remember right or wrong? Oh man, I got a right from one and I got a wrong from another. I don't know what to do with that.
Oh, wait.
Again, it's not postmodern. We have to have one answer. What's that?
I guess so.
I feel like it's not an answer, it's a conversation. Get out of here. There's no conversation in math. What's that?
It's right.
It's right? Okay, good. Yeah. I like right and wrong. It's good to have right and wrong. Okay, so A is what? A plus 4? B was 9. And then we have a plus 4 quantity squared minus parentheses a plus 4 times 9 plus 9 squared, which is 81. Which I guess we could simplify a bit, all right? So the first part's easy enough, right? It's a plus 13, right? 4 plus 9 is 13. That part's not too relatively painless, right? So we got a plus 13. And then what? So a plus 4 squared is a squared plus 4, which is 8. So we have a squared plus 8a plus 16. That's all from FOILing out to a plus 4 squared. Then I have to distribute that 9 on the middle term. That gives me minus 9a minus 36 plus 81. Now we can collect like terms here, right? So we've only got one a squared term. How many a's do I have? I've got an 8, and I've got a minus 9. So it looks like we've got 8 minus 9, which is minus 1, so I've got a minus a. And how about the numbers? 16 plus 81 minus 36, what's that? 61? So plus 61. So do I have any agreement or disagreement with a 61? I'll check it on my handy dandy calculator when you're done. So we got 16 plus 81 minus 36, 61. Great. Hey, that's also what it says in the answer key. That's good. It's always reassuring if you do what the book says. Well, it's not really the book, it's what my library says. You're like, how do you know that the quadratic can't be factored? Well, remember I told you
Where did you get the 8a from again?
I just told you that the red part goes to the red part, but if you want to see the details, here it is, a plus 4 times a plus 4 is a squared plus 4a plus 4a plus 4 times 4, which is 16, which is a squared plus 8a plus 16. So the shorter way to say that is I got it from multiplying out the a plus 4 squared. Very good question. All right, so I think that brings us to rational expressions. So what is a rational expression? Someday I'll get it. So it's basically the rational expression is a quotient of polynomials, right? You've got one polynomial over another. I really need my glasses. Example 8, 6, 9. So it's something of the form, like f of x over g of x is, well, let me not be abstracted here. Let me just get right into the examples here. Example. If I could remember a number, it would be wonderful. Example 9, we're on 9, right? Right? Example 9. So, let's see here. Suppose you have x plus 3 over x minus 6. This would be an example of a rational expression. So x plus 3 over x minus 6 would be an example of a rational expression. And then, so up to this point, I haven't talked to you guys all about domain. Why is that? Why did we talk about the domain of like a quadratic or a cubic or a quartic? I mean, we just factored them, right? No point we were like, what's the domain? It's because it's kind of silly. Like, you can stick any x you like into a polynomial, right? Because you can always add things, multiply them, raise them to powers. There's no restriction on any of that. So the domain for every polynomial is just the whole real line. Now when we get to rational expressions, all of a sudden we have division, right? And there's one number we can't divide by, right? 0, right? So what's the domain of this rational expression? What can we not have? Must it have x cannot be equal to 6, right? We need that. So the domain of this rational expression is equal to x such that x is not equal to 6. All right, and I think your book is happy with answers in this format. Eventually, we'll also want to learn about interval notation. Okay, so I'm just going to take this moment to introduce the interval notation as well. You won't need this for your homework, but for the course eventually you'll need this. So this is the same set of numbers in interval notation. It's the union of these two intervals. Like you just have to delete 6 from the real line. Okay. This notation here is, this vertical bar means such that. So you put the condition over here, you put the elements of the set over there, right? So the example I gave the earlier class would be like you could have LU student here, and then you could have went to Congo. Right, and then this would be the set of Liberty students who went to convocation this morning. Yeah? I don't know how to do any calculations on this set, but there it is. Yeah. What is the intersection of the set with its room? We did have convocation this morning, right? Okay. Exam 10. Oh man, my markers are done. What if we had x plus 3 over x squared plus 3x plus 2? What would be the domain of this rational expression? Oh, that's number 4. I've thrown markers at trash cans hundreds of times. You're the 4th student I've hit. Do you feel special? Okay, good. Sorry. This I didn't hit you in the head. So, great. What do we have to worry about? This being 0, right? How do you see where that's 0? Well, factor it, right? So this is x plus 3 over x plus 1 times x plus 2. I believe that was one of the factoring examples I showed you, like the second or third one. So what's going to get us into trouble here is the numbers what? Minus 1 or minus 2? So we need x not equal to minus 1 or minus 2. So the domain is equal to x such that x is not equal to minus 1 or minus 2. In about 2 minutes, one of you is going to ask me to put this into interval notation. So let me just get it over with and do it now. So we do minus infinity to minus 2, union with minus 2 to minus 1, union with minus 1 to infinity. So that would be the answer in interval notation. Again, the interval notation is not in your homework, which is due Saturday, right? You just need to know what I wrote in black way of thinking about it, okay?
What's that notation called, the one in black?
This is either set builder or some people call it roster.
Okay.
Roster notation or set builder notation. This one in the blue is called interval notation. So later, if I have a test and I ask you for the answer in interval notation, I mean to use intervals. Yeah. Yeah.
Is that the notation where you'll sometimes have to use brackets instead of parentheses?
I couldn't quite hear you. I'm sorry.
Oh, sorry. Is that the notation where you'll sometimes have to use brackets instead of parentheses?
Yes. We use brackets when the numbers are included, but in this case, they're excluded, so it's all parentheses, yeah. I don't really have any examples I can come up with the brackets in our current, the current universe of examples we're looking at. Example 11. Let's see here. So just one more of these domain questions. 3x plus 4 over 8x plus 2 times x minus 7. So this one is friendlier because the denominator is already factored. So one thing I should emphasize here, right? Does it matter if the numerator is 0? Can we have a fraction with the numerator 0? I mean, yeah, we can, it's fine, that's just 0. Okay, so like 0 for the numerator, no problem. 0 for the denominator, that's the trouble. That's what we gotta watch out for. When can the denominator be 0? So either 8x plus 2 equals to 0, or x minus 7 equals to 0. These are, these are the problematic for the formula. That's my abbreviation for formula. Okay, formula. So x minus 7, when's that 0? X equal to 7, right? We can all do that. That's, okay, so we need x not equal to 7, and we also need, we need 8x not equal to minus 2, right? Can you think of a better way to write that? How about divide by 8, right? So we have x not equal to minus 2 over 8, which is equal to minus a quarter, right? So the domain is x such that x is not equal to minus 2 or minus a quarter. All right. So there's, about 5 of these kind of problems in your homework for you to do, yeah. Let's go on here. Algebra of rational expressions. Let me just give you a couple of quick rules, right? So if we have a over b plus c over d, how can we add those? If we have different denominators, there's a couple different things we can do, right? The laziest thing to do is just cross multiply, right? Just like basically rewrite this as a times b plus b times c over ad. So this is sometimes a good path. For more complicated things, you really want to find like the least common multiple of the denominators to use that as your common denominator. Let me try not to talk about that in the abstract. Let me show it to you in examples as we go on, okay? So there's that. We add them like that. How do we multiply fractions? That's easier, right? Just do a times c over b times d, right? That's how we multiply fractions. How do we divide fractions? Like what if you have a over b all over c over d? How's that work? Yeah, multiply by the reciprocal is the rule. So essentially by definition, this is a over b times c over d, which is just what? ac over bd. So a good rule of thumb is to remember that the denominator of the numerator fraction goes into the numerator of the denominator, but the denominator of the denominator fraction goes into the numerator of the total fraction, right? Yeah.
Shouldn't it be d over c?
Did I do that? Oh, yeah. Thank you. Thank you, thank you, thank you. My bad. So I agreed with multiply by the reciprocal, and I proceeded to just multiply by the denominator, which is, in a word, dumb. Now, your book likes to use the notation, if you'll allow me this short manga style comment, a over b divided by c over d. I personally detest this notation, but it's in your homework and I can't get rid of it. Okay? Unlikely to see that notation on my test, even though it's in your homework. This notation, just like grade school notation for division, we don't typically use this in algebra. I've never seen this in a calculus book. Maybe. Never in a good calculus book. So this is the notation we typically would use, just like that. But anyway, it's fine. I'm not saying you can't use the notation. You can use the notation if you want. It is an allowed notation. All right, those are the rules. So, and I guess the other thing I should add is, well, let me just get into examples here. Example 12. This one's going to be kind of anticlimactic after all this jibber jabber. But if you had 2x over 3 minus 3x over 5, what would you get? What do you do there? Time flies when you're having fun. So we can just factor out the x, right? So you just really have to subtract 2/3 from 3/5 from 2/3. So in terms of 15ths, that's 10 15ths minus 9 15ths, which is 1/15. So the answer there is x over 15. And again, if you're not comfortable subtracting fractions, you can use your handy-dandy calculator. This board just does not erase well. So, example 13. So suppose we have 13 over x plus 2 divided by x plus 1 over x squared minus 4. Let's try to put this in simplest form. So how would you simplify this? So what you do, keep the 13 where it is, multiply it by x squared minus 4. The x plus 1 stays put, but the x plus 2 goes downstairs. So in this way, I go from a complex fraction to what's called a simple fraction. Right? A complex fraction is a fraction of fractions. I would like to call it a nested fraction. X squared minus 4. Hey, that factors, doesn't it? That factors, doesn't it? It's the 13x minus 2 times x plus 2, isn't it? Yeah. So what can we do here? Aha! We can cancel this with that, right? And so the answer in this case would be 13 times x minus 2 over x plus 1. And final example for today. Suppose we have x plus 1 over 3, and I'll use this for notation, divided by x plus 2 over x minus 1. How would that go? So I have, like they told me, multiply by the reciprocal, right? So what we have is x plus 1 times x minus 1 divided by 3 times x plus 2. And that would be that. Listen, I have about another 20 or so minutes of rational expression examples for you next class. And then we'll talk about section 1.1, which is linear equations. Again, I don't know why that's at the end. That's actually the easiest thing. The thing we'll end with this week will be even simpler, much simpler than this, honestly. So, anyway, thanks guys. See you Friday.